Hi students, good morning to all. Today we are discussing the topic that is Lexi user interface. In one of the design problem is spelling checking and hyphenation. What does the main motto of spelling checking and hyphenation in the sense? How does Lexi application should support the analytical operations such as checking for misspelled words? We want to checking their misspelled words and determining and how we can determining how hyphenation points and how can we minimize the number of classes. We have to be modify how we can add a new analytical operations in the document structure. Now we have to study about in a clear cut way the spelling checking and hyphenation. What are the goals and what are the constraints we need to study that? In the sense, the main goal here, we need to analyze a text for spelling errors. In the sense, the last design problem involves textual analysis, and specifically we need to checking for misspellings and introducing hyphenation points, okay, where we needed to study for the good formatting, in the sense a good layout and a good reference for the page layout. We need to checking for misspellings and introduction for the hyphenation points. Here we need to introduce a potential hyphenation sites. This is the main goal of spelling checking and hyphenation. What are the constraints of this? In the sense, we need to support multiple algorithms. In the sense, this is very similar to those we had for the formatting design problem. Already we seen in formatting design pattern as the line breaking strategies. There are more than one way to check spelling. There are one way to check the spelling misspelling words, and we need to compute a hyphenation points. So here we want to support multiple algorithms. There here we want to support multiple algorithms. Here we want to take a diverse set of algorithms, a diverse set of algorithms. It can provide a choice of space or time or quality, whatever it may be. It is very easy to add a new analytical operations or new algorithms as well. Okay, here we don't tightly couple algorithms with document structure. We don't want to take like this. We also want to avoid writing the functionality into the document structure. So this goal is even more important. But in formatting case, misspelling we are checking spelling words and hyphenations, or just it is two kinds of analysis. Just we may analyze its lexi should support or not. Okay, now we study about here. There are actually we need to study about two pieces of this puzzle of spelling checking and hyphenation. The first one is we are accessing the information it to be analyzed, which we have scattered over the glyph. Glyph will act as an abstract class for all the objects in which these are present in the document a structure. So the next one is the next point. First point, we're accessing the information, we must be analyzed. And coming to the second piece of this, we are doing the analysis for accessing scattered information, and we are encapsulating access and traversal. Right now we are studying about our glyph interfaces, how the user uses an integer index to let clients refer to that particular children. Okay, now we need to study about the next solution of encapsulator traversal. How we are analyzing this iterator pattern. We are studying about this iterator pattern. We need to understand what that exactly we need to encapsulate an traversal and analysis here. So the iterator pattern, what here it captures the techniques for whatever we need to supporting accessing for the information and traversal over the object structures. Okay, it is a very important applicable not only to composite structures but to collections as well. Here it abstracts the traversal algorithm and shields clients from the internal structure of the objects whatever they are traversing. The main intent of iterator to encapsulate a traversal algorithm without exposing representation details to the callers. So we need to use here a glyph child enumeration operation. So the iterator pattern illustrates once more how encapsulating the concept that it will varies help us to gain a flexibility and reusability. It should be flexible and it should be a reuse. Again, even we get the problem of iteration in depth. The iterator pattern covers many more nuisances and trade-offs than we have to be considered here. So this is an example of pre-order iterator. See, look at this diagram: iterator 1, iterator 2, iterator 3, and A is and punctuation marks. It's a 4. Okay, this is the diagrammatic representation of what we are studying about. This is the figure shows to you from all indicators here. We are encapsulating the analysis. We need to encapsulate the analysis in a separate object here. Look at this object iterator. This is the object structure. We have done many times. We could put the machinery for a given analysis. Here we use an instance of this class in conjunction with a suitable iterator. So iterator would carry the instance to each glyph in the structure. So the analysis object here to perform a piece of the analysis here. How we can analyze at each point of the traversal. So the analyzer accumulator A, the analyzer accumulator here A is there nama, the information of interest like characteristics in this case small a as the traversal proceeds. This is the fundamental approach of how the analysis object distinguishing of different kinds of glyphs. We are using child enumeration operation. This is an example of pre-order iterator amma. And then we have to study about here iterator pattern and visitor pattern. We need to study here iterator pattern is coming under the concept of object behavioral design pattern. Okay, behavioral design pattern, we need to represent how the classes and objects communication, interaction, how it will be. Now the main intent, what does the pattern do? A short statement of intent. We are accessing elements of a container. We are accessing in a elements of a particular container without exposing its representation. We are accessing elements of a particular container. It is the main intent of iterator. Coming to the applicability, where it is used in the sense, listen carefully, where it is used, it requires a multiple traversal algorithms. It requires a more than one traversal algorithm over a container. And one more key point, it requires a uniform traversal interface. Only single traversal interface, how we want to communicate the user and the mission over a different containers. And the last applicability of this concept, when the container classes and traversal algorithms, it must vary independently. What I am saying, this is the applicability of iterator in the sense, first of all, we need to require multiple traversal algorithm over a container, and we need required to access a uniform traversal interface over different containers. And one more, when the container classes and a traversal algorithm, it must vary independently. Coming to the structure, how the graphical representation of the classes and objects, how the scenario it looks like. Now the structure, we want to look at the structure here. We are taking one aggregate a class like a glyph. We want to create iterator some method. In this we are the relationship between aggregate of the subclass here, a concrete aggregate. Okay, in that method we are writing create iterator of function. What it will returns here, new concrete iterator of this. Okay, here this is the relationship between aggregate glyph and iterator. Okay, iterator, the main methods of first, next, it will be done or there, is this the correct item or not. Okay, this is a structure graphical representation of the how the classes related to one another. And coming to the iterator, how the sample code, how the sample iterator pattern can be applied to any STL container. STL in the sense, what are the templates, what are the framework library, how the standard template library container, how can be applicable for the pattern of iterator. Iterators are very useful in C++ standard template library. Here we are writing some code in C++ advanced data structures. It's like a int. If you can give the main int arguments and characters of arguments, okay, something parameters, if we have to take some parameters, vectors, some string arguments. For if we have to take some condition here, int I is assigned to be 0, I less than arg c, I will be incremented. So I'm writing some argument here, args dot push underscore back string of arg v of I. For vector, a string scope resolution operator iterator I args dot begin of some function. We have to begin, and I factorial equal to args dot end. Then I will be incremented. Then C out, how out in the sense the output will be I, what value it will become, and C out end I. Return the value 0 here. Now if we have to write the for loop condition here, glyph scope resolution operator iterator, I will be assigned to glyph dot begin. Next I factorial will be given to glyphs dot end. Next I will be incremented. This is the sample. Just if we have to return some, taking some initialization methods and like parameters, something arguments, and if we have to take some vector strings, iterator, how the access elements of a container without we are not exposing its representation, we are present here the sample iterator, how the pattern will be applied to any standard template libraries. Here glyph, it will act as an abstract class, how we are accessing the methods and functions, how we are implementing there, and here how these objects are present in the document structure particularly. And then we are study about consequences. What the consequences describes the results of what it will be. Okay, the result here, it should be a flexibility and it should be reusability. Here the flexibility, what we had to say here, we are taking aggregate and traversal or independent. Aggregate and traversal algorithms are independent, and we are taking here a multiple iterators, more than one iterators and more than one traversal algorithms. It will describes the result of this, what they are taking this application. Why we are taking some additional communication over between iterator and aggregate operators. Okay, and now then we can see here what are the implementation of iterator. Implementation which when the design situation it is very suitable, we are implementing the particular code by you are supposed to do that, which situation we are used, which situation we are implemented that. Okay, internally it should be external iterators. What are the external iterators we are taking? Their internal versus external iterators. Internally we are taking some iterators. Iterator, the main intent here, without exposing its representation, we are accessing the elements, we are accessing the elements in a container. Okay, in a container, the actual a representation here, we are violating the object structure encapsulation. Okay, in the sense what here we are studying, the iterator pattern has three important consequences here. The first one we need to study, it support variations in the traversal of an aggregate. In the sense, it supports the violating object structure encapsulation and internally versus external iterators, how it will be taking there. In the sense, I need to explain the consequences. Listen carefully. We need to take some complex aggregates. It may be traversed in many ways. For example, code generation and semantic checking. Semantic checking, syntax and semantic checking, it involves traversing parse trees. So the code generation may traverse the parse trees in order or pre-order, whatever it may be, if you have to prefer. Iterator, it make it easy. Iterator, it make it easy to change the traversal algorithm. Just we need to replace the iterator instance with a different one. So you can also define iterator subclasses. We need to support a new traversals. Understand, ma? It is very make too easy to change the traversal algorithm. Just we need to replace the iterator instance with a different one. You can also define iterator subclasses. We need to support a new traversals. Okay. Here we need to study a synchronization overhead in multi-threaded programs and batching in distributed and concurrent programs. In the sense, we need to take some iterator, it will be simplify the aggregate interface. In the sense, iterator traversal interface, it obviously it need for a similar interface in aggregates. Thereby, we need to simplifying the aggregate interface also. We are studying here synchronization, how the synchronized in multi-threaded, more than one thread, it will be done at a time. How the program more than one traversal can be pending an aggregate. Here an iterator keeps track of one traversal state, so it can have more than one traversal in a program at once, in progress at once. This is the implementation. Here we are using noun uses. In C++ we are using there, and standard template library iterators, JDK enumeration and iterator, and then unidra iterator, only single. And coming to the visitor, here we need to define actions. At each step of traversal we need to define actions, and we need to avoid wiring actions into a glyph. So iterator calls a glyph. You are taking at each node, we want to accept a visitor also. We need to accept a visitor. Okay, accept function, what the accept function calls back on visitor? A form of a static polymorphism based on a method overloading by type. What is the meaning of the accept function? It calls back on visitor. Okay, a form of a static polymorphism. What is the meaning of the polymorphism? One to many forms we can access there in dynamic binding, linking, whatever it may be. Here we are based on a method overloading by type, especially by type. Okay, here the visitor, what the code here? Void is nothing, character, we are taking some scope resolution operator, accept function, in that we have to return visitor at the rate of v. In open brace, v dot visit of this function, a class name visitor. In public we are accessing these methods, a virtual void visit of character space ampersand, and virtual void visit rectangular space ampersand, virtual void visit row ampersand, etc. These are all relevant. These are all very relevant glyph subclasses. Okay, we need to study here exactly the visitor design pattern. Okay, visitor design pattern is also a object behavioral design pattern. We need to get here a character code. From each character glyph we need to get a character code. Can you define get a char code, a function of that particular operation just on character function class? We need to check words there accumulated from a character glyph. So we need to combine with a preorder iterator. Here we are taking some class name, spell checker, visitor, public visitor, public colon, a virtual void, visit of some character ampersand. Already I said you this is the public methods, and private method we need to standard strings accumulated. We have to calling that. This is nothing but accumulating words. How we want to accumulate the particular words in the document structure, we need to support the lexi, a spelling checking performed when a non-alphabetic character it will be reached. Okay, this is the concept, how the diagrammatic representation of this particular object structure, we are checking some spellings and hyphenation points. It will be performed when a non-alphabetic character it will be reached. Okay, now we are studying about here interaction diagram, how the interaction diagram explains you in the sense here. Listen carefully. The iterator controls the order in which accept function is called and on each glyph in the composition. How we are studying now, we have here, we defined there the iterator, how the iterator controls the order, how the iterator controls the order in which accept function is called on each glyph in the composition. Here we are taking accept function, then we visit the glyph to perform the desired action. So the visitor can be subclassed to implement various desired actions. Here we need to check here a character, a double quotes, another character within double quotes, a spelling checker. Okay, here we can take some diagrammatic, how the interaction diagram illustrates how the character glyphs and the spelling checker objects work together. Look at here. First of all, we need to accept spelling checker, ma'am. Then we need to visit this in a spelling checker, and then we need to get some character code there, and we need to perform accept a spelling checker, and we need to interact with the visit of this function, and then we need to check the completed word here, and then if you need to get the care of a code function. This is the concept of interaction diagram. This is the hyphenation visitor, how the hyphenation visitor get the character code from each character glyph. So we need to examine here the words, how we can accumulate it from a character glyphs. Okay, so at potential hyphenation point we need to insert a like class name hyphenation visitor, public visitor. We need to take some void visit, they are visit some characters, rectangles, rows for all relevant glyph subclasses. So next we need to study about discretionary glyphs. Discretionary glyph in the sense we need to look like a hyphen when at end of a line, when at end of a particular line it has no appearance, otherwise the compositor considers its presence when we are determining or constructing the line breaks. Here we are look at this diagram. Here some A within double quotes, I discretionary, and coming to the I O Y. This is the aluminium alloy or aluminium alloy. Is like we are giving some figure representation of a discretionary glyph. It looks like a hyphen when at end of a line. It has no appearance, otherwise it considers when we are constructing the line breaks. Okay, now we are studying about here a discretionary glyph. It has one of two possible appearances, ma'am, depending on whether it is the last character on a line. If it's the last character, then the discretionary it looks like a hyphen. If it's not at the end of a line, then the discretionary has no appearance whatever. So we need to check the discretionary, its parent, a row object, to see if it is the last child. So the discretionary makes this check whenever it's called on to draw itself, or we need to calculate its boundaries. So the formatting strategy, it will treat the discretionaries white spaces, making them making them candidates for ending a line. So we are following the diagram shows how an embedded discretionary it can be appeared. Okay, this is the diagrammatic representation of discretionary. Now we are studying about visitor pattern. It is also one of the main concept of visitor pattern in object behavioral design pattern. Visitor is also a object behavioral design pattern. What the main intent of visitor pattern in the sense, we need to study about what the main intent here in the sense, we need to centralize operations on an object structure so that it can vary independently but still it behave polymorphically. In the sense, we need to centralize the operations on a particular object structure so we can vary independently, still it behave like polymorphically. Okay, so what are the applicability of visitor pattern in the sense, when we are defining the classes, it may have many unrelated operations. The class relationships of objects in the structure, it rarely changes, but the operations on them, it will be oftenly a change. So here the algorithms, it will keep a state that's updated during the traversal algorithm. Okay, so this is the structure in the sense, a graphical representation of how the classes and objects communicate. Here look at this is the client, a client, and the client will give the relationship between object structure and it related to the elements. So whatever you have to accept a visitor, and visitor have some methods and concrete visitor, and we are taking some concrete elements, how the relationship, what are the written values of visit concrete elements of this function, and we need to return v dot visit concrete elements of to this function. Okay, is the relationship between how the classes and objects communicate. This is the structure, this is the graphical notation of classes and objects. Okay, now we are moving to the visitor sample code. The sample code look like this ma, it's nothing but already we are learning there. We are using accept function and hyphenation visitor. Okay, hyphenation visitor, hyphenation underscore visitor. Here also same, we are accessing some accept hyphenation underscore visitor. And then the consequences, what it describes here, results, it should be flexibility. The visitor and object structure, those are independent and these are localized functionality, and it is very circular dependency between how the visitor and the element interfaces. We are dependency between those objects. We are visitor to new we are visitor returns new concrete element classes. Coming to the implementation concept, we need to double dispatch classes, and we are general interfaces to the particular elements of object structures. What are the known uses here? We need to study the program node enumerator in Smalltalk AT compiler, and we are taking some iris inventor scene rendering, and we need to handle different backends. These are the known uses. Finally, I concluding these remarks, we are reusing the design, and we are designing the vocabulary in uniform interface, and we need to understanding how the reconstructing and the team communication, how it will be, and we need to provide the basis for the automation, and we need to think about a design in a new way. Okay, this is the concept of spelling checking and hyphenation. We are using here two patterns, that is iterator pattern and visitor pattern. We are look at the main intent of visitor. We need to support the lexi here. We need to provide centralized operations on an object structure so that they can vary independently, but still we need to behave polymorphically. And coming to the iterator intent, without exposing its representation, we are accessing elements over the container of a container. Okay, this is the main theme, spelling checking and hyphenation in the sense lexi should support to you. We need to check the spelling. We need to support analytical operations such as checking for misspelled words, and we are determining hyphenation points, and how can we minimize the number of classes, and how we can modify. We are adding a new analytical operations. This is the main motto of spelling checking and hyphenation. Thank you, ma.